The cell phone is 68 years old. That's older than Mr. T, Barry Gibb, or David Hasselhoff. Yep, the cell phone is older than all of them. The device that you can currently find in your pocket is now more powerful than the computers used in the Apollo missions that put a man in the moon. Today, we can't imagine a world without cell phones, even though humanity did just fine without their current iteration for more than 2,000 years without descending into chaos. Well, for the most part. Let's take a quick look at where the cell phone's been, how it works, where we are now, and where we're headed. Strap in because it's a crazy ride. In 1946, the first mobile technology was brought to the US by AT&T and was called MTS, or Mobile Telephone System. It weighed 88 pounds, so not so mobile, used vacuum tube technology, and revolved around a powerful base station that could send signals as far as a 50-mile radius. It was more like a walkie-talkie than the phones that we're used to now, where only one person could talk at a time and you had to use an operator to connect with who you were trying to reach. Our next iteration, IMTS, or Improved Mobile Telephone Service, allowed for getting rid of the operator and direct dialing. Revolved around a 200-watt transmitter that could cover an entire town, and the receiver weighed only 20 pounds. The area covered by the transmitter was called the cell when it was conceived in 1947. These transmitters or towers now had the ability to use different frequencies, which allowed for better coverage and less interference. Although the bones of the system was in place for cellular phone technology, switches, integrated circuits, and the handover technique were years behind. Moving on to the first G, or first generation tech, which was not seen until the 70s in the US, this tech was used mostly by the government and was analog, which follows the pattern for most technology development where, because of cost and size, it doesn't really get realized for public consumption until it's affordable and consumable. In the 90s, we see 2G. 2G went from analog to digital, providing better quality and capacity while lowering the cost to a point where it was accessible to the general public. The focus at this point was still voice communications, and data speeds were somewhat slow. At this rate, only very small files could be transferred over the network, like ringtones. It's the advent of 3G in the 2000s where the industry begins to focus on cell phones as digital content devices and have the technology to transfer data speeds much faster. Now, other than just calling someone, a user could share photos through text messaging and navigate the internet. We start to see a shift to nonverbal communication via mobile phones. Our current 4G technology was introduced to the public in 2008. We now see speeds up to 1 gig per second, which has fully allowed our cell phones to be full-blown on-demand media and communication devices. This technology allows the general public to edit and send documents, be a part of video calls, stream music and TV shows on demand, as well as send videos and photos via MMS messaging on a highly dependable network with high reliability. So, how do these devices work? Well, first off, the device needs to connect to a network. The network consists of cells, antennas, and spectrum. Cells are grids that divide an area into cells of up to 250 square miles and use sets of radio frequencies or channels to provide service. Antennas aren't necessarily the big towers we envision. Usually they're as big as a boombox and act as a base station that can link users to the phone network, the internet, or other wireless networks. They become larger in sparsely populated areas where they need to cover more ground. Spectrum is the frequencies themselves, and it is a finite resource. Wireless signals travel through the spectrum on a particular frequency, and if another signal travels on the same frequency, there is interference. There's only so much of it to go around for all wireless communication, and we are currently in a shortage of it. GPS, cell phones, radio, and TV all use spectrum, so you can imagine how essential that is. When we use our cell phones, the device searches for a signal to access service, transmits information to the network to verify customer information, and if calling a landline, the phone is switched by the carrier to the traditional landline system. If calling another wireless number, it may go through the landline network to the recipient's carrier, or it could get routed within the wireless network to the cell site nearest the recipient. If calling long distance, it will be routed through the long distance center. This all happens even before you say hello. Digital technology converts your voice into binary code, and that gets related to data packets to the network to the receiving phone. On the other end, the process is reversed, and the person hears your voice. This makes communication and data transfer much faster, reliable, and portable. Lastly, this technology is mobile because of the handoff process. As you move with your device, the network can tell when your signal gets weaker and hands off your call to an antenna with a stronger signal. This happens even if you're not talking. According to the Pew's Research Center study in 2014, 90% of all adults have cell phone in the US, split pretty evenly between all ethnicities and age groups other than 65 plus. This technology that is spread through every education level, income level, and community type, rural to urban. Another survey done by the Princeton Survey Research Associates International in 2013 finds 81% of adults text, 60% access the internet from their phones, while half of them email, use apps, and utilize GPS on their mobile phones here in the US. The cell phone has been through many changes in form, going from huge military use backpack form that needed two people to use to the still too large zero-G phones until the late 80s, early 90s, where we see first G phones that Zach Morris and Crockett and Tubbs used on those famous TV shows. Through the advent of the first flip phone and the candy bar forms of Nokia, and we start to see the form try and get more sleek like Neo's phone in The Matrix. It then gets very tiny, and finally getting to the multimedia phones like the BlackBerry for business users and Jobs' iPhone that really made the cell phone a media powerhouse, to the newest craze, the phablet. If we look forward, the Google Glass and the wearables trend of the smartwatch are starting to take hold, but point to the eventual phasing out of the cell phone as a separate device that we have to hold all the time, but more to something that more seamlessly interfaces with a user. There's been speculation of bioengineered solutions such as implants in the skin with an NFC chip to pay for things by swiping our wrist over a terminal, and even ocular implants to view the output of an integrated computer. But all these solutions can also cause many more problems like alienation, less sociable people, and tragedies that can be caused because of loss of focus. It's up to society to create a balance, but that takes time. Technology should take a breath before always going forward to contemplate the side effects of what it brings to society as a whole.